Hello, my name is Arman Dolatabadi. I'm a computer science major at the University of Alabama in the Randall Research Scholars Program. I'm studying under Dr. Luca Campanelli in the Department of Communicative Disorders, and today I'll be going over our project examining morphological complexity in a multilingual eye-tracking corpus. Okay, so let's set the stage for today's discussion. Language processing theories give us an excellent glimpse into human cognition. But there's a problem. The vast majority of them are based on English. With its unique syntactic and morphological characteristics, relying solely upon English risks creating theories that fail to generalize to other languages. This project seeks to address this gap by examining morphological processing in many different languages. By disentangling language-specific and universal features, we aim to enrich our understanding of human language processing and its broader implications for linguistic diversity. Okay, so let's start out by reviewing some key background literature. So why is cross-linguistic work even needed? Most theories of language processing are based upon English, as I went over earlier. But what does language processing even mean? So when I refer to human language processing, I refer to how we parse a sentence in real time during reading or listening. But can two languages be so different such that this is even a problem? Yes, and English is especially different. It has tons of different odd quirks. It's an analytic language with no tones, strict word order, a highly opaque writing system that relies highly upon sight reading. These features are not super common across other languages, and we miss very common features when we focus specifically on English. But regardless, focusing on any one language for models of cross-linguistic processing is highly problematic. If we use Arabic or Chinese as a model for cross-linguistic processing, we would have similar problems. We need cross-linguistic research to actually disentangle what's universal and what's language-specific. So here's a graphic. That arrow, that blue dot being pointed to by the arrow, that's English. And as you can see, it is totally different from practically every other language on the planet. It just doesn't share that much in common with other languages, not in terms of phonology, grammar, syntax, morphology. And so if we were going to build a cross-linguistic model of processing based on English, it just wouldn't be very representative of the world's languages. We can't really tell what's universal and what's language-specific, especially with English. So we see that there's a need for cross-linguistic research. So let's talk about a bit about the features that we're trying to study. Here's our first primer. There are some languages like English which have a low morpheme per word ratio. What does that mean? Morpheme means a bit of meaning. So you see the word house in that sentence. House means house. It means home. That just has one meaning. So house is one morpheme, but also in English, it's just one word. So we call languages like English analytic or isolating. Then we have languages like Turkish, where we have one head word and then we just add tons of other suffixes and we represent the entire meaning of a single sentence in one word. We call languages like Turkish agglutinating, which, of course, it's in a broader spectrum called the synthetic spectrum. Another tangible difference in processing that we see deals with syntax rather than morphology. So let's look, for example, at subject-relative clauses versus object-relative clauses. The difference in these two terms lies in the focus of the given clause. In the first sentence, the senator who's attacking the reporter is the focus of the sentence. Whereas in the ORC, we place our focus on the senator who's being attacked. So in English, the former sentence is a lot easier for us to process. But in Chinese, there really is no such difference. They're about the same. So let's say that we were going to base a model of cross-linguistic processing on English. We would totally miss this difference in processing. We would assume that just because English has this processing benefit to subject-relative clauses, that it applies to all languages, which is not true for every language. Okay, so let's summarize our background. First, we know that all languages differ quite a lot from each other, English especially so. Thus, we can't just focus on a single language to build universal language processing theories. That is, language theories about how humans parse a sentence. Further cross-linguistic work is needed to understand what's universal and what's specific. So we have two questions that we're trying to answer here. In this project. First, how do morphological features relate to language processing difficulty? And second, are there any clusters of language processing indices relating to language features? We already talked about language features, but how do we systematically track them? Well, we have corpora for that. So these features that I've gone over have specific and sometimes multiple listings in a freely available online corpus called the World Atlas of Language Structures, also known as WALS. Through WALS, we can directly view the status of certain features without the need to collect our own data. This includes features that we've already gone over, like heavily suffixing or prefixing languages, or the number of cases. WALS contains data on individual languages, which is essentially any language or dialect of interest. And then each one of these languages is indexed by a unique code that then has a list of all of these features and the status of that feature. WALS is really a convenient and standardized way to organize our study. It contains all the features we could ever want in one place. Then we have our processing component, which is MECO, the Multilingual Eye-tracking Corpus. So there are 13 languages, mainly across Europe, that are included in the corpus, and each language has 12 Wikipedia-style entries that were read by an average of 45 participants each. Eye movements were tracked during reading, and for each word, several measures were included, such as the total amount of time that was spent reading a word, or the first fixation duration, or the number of times the eyes looked left or right, et cetera, et cetera. There are tons of these different measures. Now let's look at the languages themselves. Again, most of them are European, but 5 of the languages are not Indo-European. That is, they're not related to the majority of European languages. There are 5 total languages here, language families here. And for a set of mostly European languages, that constitutes great linguistic diversity. And also impressive is the fact that 6 of these languages are just not very commonly represented in the literature. Less than 1% of current studies actually include these languages. So publishing a paper including these languages specifically would be really good for us. So let's talk about how we plan to analyze this data, how we plan to test our hypotheses. So we're going to use mixed effect regression analysis to analyze individual language features in the WALS. In our project, we will check each one of these features for patterns in the eye tracking data. For example, many synthetic languages have highly flexible word orders. How will fixation durations look for inflexible languages like English as opposed to more flexible languages like Turkish? Specifically for this, we expect that languages with greater word order flexibility will show greater fixation durations per word. Then we look at cases. Specifically for cases, we would expect to see higher fixation durations on marked words marked by case, in languages with higher numbers of cases, and in languages with fewer numbers of cases, those fixation durations would be higher on function words like at or if or then. We also have an exploratory phase where we will use data-driven brute force analysis to form clusters of eye movement measures that separate features. And we would expect these to be separated by typology. Okay, let's talk about our next steps. So first, we're going to complete our current project. Second, we expect to perform a similar study in the future that swaps out the eye movement measures for something like EEG or fMRI. The main things that we seek to learn from this experience is everybody has the same hardware. All of us have the same brains. Brains don't differ from Sri Lanka to the United States, but languages do differ, on the other hand, and thus so does language processing. So in doing this cross-linguistic research, we're going to contribute to the cross-linguistic field and build better models of processing. And in discriminating between universal and language-specific features, we hope to contribute to the overall field of cognitive science. Any questions?
On slide 7, why did you specifically compare Chinese and English?
Okay, let me go back to that. Okay, so Chinese and English. So I talked about earlier how there's this spectrum of languages from synthetic to analytic or vice versa, right? So specifically for English and Chinese, both of them are on the same end of this spectrum. They're both considered to be analytic languages. Really, the word structure in Chinese and English is very similar. But we still notice that even though they're very typologically similar, there's some sort of difference in processing here that deals with syntax. Thus, it's not just a typological difference that's going on here. We need to look at many different language features outside of just broad morphological differences.
Yeah, is there any usefulness in, like, if you're talking about Western European languages, is it useful to investigate like Latin as like a common root language? And then can you extrapolate findings from that to other languages?
Okay, that's an interesting question. I'm not entirely convinced that this would be useful for today's cross-linguistic studies, because again, all of these languages have diverged and changed so much that there are many different features that existed from Latin that no longer exist in its daughter languages. So for example, I talked about the number of cases in these different languages. Latin is a very case-heavy language, whereas if I look at Spanish, it's totally different. It's simplified significantly. So maybe there could be some sort of cross-linguistic study for ancient languages, but really the only types of languages we want to be looking at for modern research are modern languages. Extrapolation from parent languages wouldn't work so well.